And routine. For today's application, we are going to study about the process dynamic behavior, and we are going to focus on the first order system. This first order system is divided into two categories, which is the first order system and the first order plus dead time system, also known as FOPDT system. In S domain, the first order system is represented by the first order transfer function. The transfer function is the equation that relates the input to the output of the process. So in this equation, y is the output and x is the input. The output response of the process is depends on the process characteristic, which is k, the process gain, and also tau, the time constant. For the first order plus rate time system, similar transfer function is used with additional of the third transfer function parameter, which is the C0, also known as dead time or time sleep. There are two objectives of conducting the lab session. First is to simulate the first order system in Simulink MATLAB, and second is to study the effect of process characteristics to the process response. I'm going to show you on how to use MATLAB to obtain the dynamic response of the first order system. In the MATLAB homepage, there are two methods to launch the Simulink start page. First is by typing the Simulink command in command window, and the second one is to click at the Simulink icon in that homepage. In Simulink, the transfer function is represented by transfer function block, which listed in continuous system element in Simulink library browser. Add the transfer function to the model. By using its default transfer function, the process gain is set equal to 1 and the time constant also equal to 1 second. In order to obtain the S curve process response, so we use stack input as the input to the transfer function, which is listed under source element. And in order to see the response of the transfer function, we use scope, which is listed in the sync element. So now we have the first order system with the step signal as the input to the transfer function. Once the plot diagram is filled, it can be simulated by pressing the run button, the green button at the menu bar. And the simulation time can also be changed at the Simulink menu bar. In order to study the effect of process characteristics to the first order system, we're going to vary the transfer function parameters k and tau. We can only change one parameter at a time. In order to study the effect of process k, the gain value is changed to 3, 5, 7, and -2, while the time constant value is fixed at 1 second. And to study the effect of time constant, the time constant value is changed to 3, 5, 7, and 9 seconds, and the process gain value is fixed at 1. In Simulink block diagram, the process gain value is changed by changing the numerator coefficient. And in this example, the default value is 1 is changed to 3. To study the effect of the time constant value is changed by changing the denominator coefficient, the first denominator coefficient. And in this example, this denominator coefficient is changed from 1 to 3. To obtain the dynamic response data, we need to use the two-stitch block. And using this two-stitch block, all the data will be available in workspace. To study the effect of dead time in the first order plus dead time system, we're going to vary the dead time value to 3, 5, 7, and 9 seconds. And at this point, the process gain value is fixed at 1, and the time constant value is fixed at 1 second. In Simulink, the time delay is represented by the transport delay block. So this block needs to be added to the previous first order system to create the first order plus dead time system. This system represents the first order plus dead time system, where the transport delay block is added after the first order transfer function block. The value of time delay can be changed by changing the time delay parameters in the transport delay. Similar to the previous first order system, the time delay value is sent to the workspace in order to capture the dynamic data.